Chapter 10. Running out of holders? It's time for the array. In this chapter, we will look at a data holder that is very useful in programming languages. It is called the array. The array is used to hold several values of the same type of variable. We'll start with some analogies before we look at the array itself. In this chapter, the array, keeping what's alike together. Members bound by their type. Loops work well with arrays. Programming with arrays. Assigning an array. Printing an array. Copying an array. An analogy for the array holder. The array is designed to hold a collection of data. When we deal with a large collection of data, we need to put each piece of data into a separate variable holder. If you have, let's say, 50 data items, you would have to sit and think of 50 variable names, one name for each data item. That can be difficult, since there are only 26 letters in the alphabet. You could certainly use A, B, C, D, and so on. But what would you use after that? The array type holder provides a useful technique for holding large quantities of information. In order to understand the array, let's look at an analogy. Think of a large chest of drawers. Most bureaus have only 3 or 4 drawers. Imagine if you had a bureau with 50 drawers. You could refer to each drawer by number, drawer 1, drawer 2, drawer 3, and so on, and so forth. You would put clothes in each drawer, but the clothes would differ from drawer to drawer. Socks would be in drawer 1. Shirts would be in drawer 2. In drawer 3, you would put sweaters for spring. In drawer 4, you could put shorts. In drawer 5, you could put jeans, and so on. Each drawer has different items: socks, shirts, sweaters, shorts, jeans, but each of these items is an item of clothing. All of these items belong in the bureau because they are clothing items. An array is similar to a bureau. It has many different drawers, or slots, called members. Each member is identified with a number. The array is used to hold different values that are of the same type. You could have an array of integers. Let's look at a bureau that has a different integer in each drawer. Compare it with the bureau of clothing we just discussed. See Figure 10.1. Figure 10.1. 2 bureaus are shown, one with different clothing items and another with different integers in each drawer. Drawer 1 socks, drawer 2 shirts, drawer 3 sweaters, drawer 4 shorts. That's in the bureau of clothing. The bureau of characters has drawer 1 being Z, drawer 2 being A, drawer 3 being M, drawer 4 being Y, and drawer 5 being B. Back to the text. Caution. In the programming language C++, the array drawers members are numbered beginning with 0 instead of with 1. So if you are trying to reference the 7th member of the array, you will need to use slot 6 because the numbering started at 0. If you wanted the 3rd member, you would use slot 2, and so on. An array is used for a collection. An array is used for a collection of items. Each item is unique, but it does belong to a common type. Think about a collection of MP3s. If you were really organized, you might make an Excel file with a number for each MP3 you own. Then you could generate a list of MP3s like the following. MP3 1. My Chemical Romance's The Black Parade's all-time hits. MP3 2. Radiohead's In Rainbows. MP3 3. U2's How to Dismantle an Atomic Bomb. MP3 4. The Best of Beethoven. MP3 5. Evanescence's Fallen. The collection is a collection of MP3s, and each MP3 is unique. Rather than referring to each MP3 individually by its title, we refer to each MP3 by its number in the collection. MP3s 1, MP3 2, MP3 3, and so on. What we have created is an array of MP3s, a collection of MP3s. Why is the array used? The array is used to group together variables of the same type, but differing in values. As you learn to program, you may need to deal with large quantities of data. For example, if you know that you will have to store 50 names of people you know, then the array is a good choice holder. Then the array is a good choice of holder for this information. The array would allow you to put each name into a drawer of a bureau, so to speak. Instead of calling each drawer a drawer, we call it a name. Name 1, name 2, name 3, name 4, and so forth. Otherwise, you would have to come up with a list of unique variable names, like first friend, second friend, third friend, and so on. When we get to array syntax, you will see how much easier it is to create 50 variables that are unique without having to type a variable name for each. Array syntax. When you declare an array to the compiler, you are telling it to create a large bureau with each drawer of the bureau numbered. After you declare the array, you can start to load the array by assigning each member or drawer a value. The key thing about array syntax is letting the compiler know how many drawers it should set aside in memory and what type item should it expect to store in each drawer. So far we have used the int, char, double, string, and boolean types. We could make an array of each of these types if we wanted. Example. Let's look at a declaration of an array of 50 members where each member is an integer. Just as we did with the collection of MP3s by naming each MP3, MP3 1, MP3 2, and so on, we need to come up with a name for each for the collection. Let's use the term group. Int group 50. Int type group name 50 number of members. Notice that brackets were used to let the compiler know it should create 50 integer holders. If the brackets had been missing, the declaration would have looked like a straightforward integer declaration. Int group. That would have meant we were declaring one integer called group. The array defined earlier, however, enables us to create 50 integers, all with the common name group. Here's how these integers would be named. I need to forewarn you that in C++, the array members are numbered beginning with 0. Let's look at how each variable is named, first in English and then in a programming language. So we go from English to a programming language. Group 1 becomes group 0. Group 2 goes to group 1. Group 3 becomes group 2. Group 4 becomes group 3, and so on. Group 48 becomes group 47. Group 49 becomes group 48, and group 50 becomes group 49. There is no group 50 in the programming column because group 49 is the 50th member of the array. That's because we started at group 0 instead of group 1. The brackets are used to identify the member number, draw number, of the array. See Figure 10.2. Figure 10.2. Each member of the array is shown with its value inside of it. Group 0 is 14. Group 1 is 28. Group 2 is -3, going forth. Group 47 is 79. Group 48 is 157. Group 49 is 2. Caution. Note that values have no correlation with the number member where they are stored. Different types of arrays. Let's declare some other arrays using different variable types. We'll start with an array of strings to hold the collection of phone numbers. We'll declare an array of 35 strings. String phone book 35. Look at this table which indicates each part of the declaration. Type, string, array number, phone book, number of members, 35. Another example of an array would be one used to hold a collection of real numbers. Imagine that you were trying to store the checking account balance for a group of 40 individuals. Each person would need a slot or drawer in the array for her balance. Consider this declaration followed by a table that clarifies each part of the code. Double, account balance, 40. Type, double, array name, account balance, number of members, 40. Assigning values to an array. Now that we have declared a couple of different arrays, it's time to load an array. What that means is we will assign each member of an array a value. Let's start with the phone book array we declared previously. Consider this list of members and the value each slot contains. Member, value. Member phone book 0, 5552222. Phone book 1, 5554567. Phone book 2, 5552345. Phone book 3, 5554567. Phone book 4, 5551234. Going on. Phone book 31, 5555678. Phone book 32, 5556789. Phone book 32, 5559876. Phone book 34, 5554567. We have only used 18 slots in the array. The other 17 are empty and have nothing in them, not even blanks. The compiler considers them to be uninitialized. This means that they have not been given any value. Remember that if you try to work with a variable that has no value, the compiler will have problems. Note, if you try to use a value that has not been initialized, such as the 36 member in a 35 element array, the compiler will use whatever value it finds in that memory location, which could be anything. At best, your program will have seemingly random errors, and at worst, your program will crash your computer. Now another point to notice about the array values in Phonebook is that integer values have been mixed with the dash. Yet we know that this array has been declared as an array of strings. A string type is useful because you can mix characters with numbers and still store them in one variable holder. The next point to consider is how we will assign values to members of an array. Of course, you could use several assignment statements to assign the array, like this. Phonebook 0 equals 6412222. Phonebook 1 equals 1234567. Phonebook 2 6542345. Phonebook 3 2344567. Phonebook 4 8901234. Going on ... Phonebook 3 3455678. Phonebook 32 567 6789. Phonebook 33 345 969876. Phonebook 34 432 4567. But that seems to be a tedious way of assigning values to several variables. You might also start to think, what is the point of the array? Because we don't appear to be saving any time at all. The answer to this tedium is found in the application of a loop to our problem. A loop is ideally suited for accessing members of the array efficiently. The real power of the array is using it in conjunction with a loop to save time. How to use loops with arrays. In order to understand how a loop can be used in a conjunction with an array, let's start by comparing the members of the array with a control variable from a for loop. If you recall, the control variable is the variable that is increased or decreased during the loop. We'll start by declaring an array of 10 members, each of which is an integer. Now, next to it, we'll declare a control variable that will be used in a for loop. Int list 10, int x. The first step in understanding how a control variable might be useful with an array is to think of the control variable as a variable that moves through the members, slots or drawers of an array. The control variable changes during a for loop. If we use it to move through the array members one at a time, we can use a loop to access the members more efficiently. Consider this list of array members, slot position, and the control variable values. Member, slot, $, control variable value. List 0, 0, 0. List 1, 1, 1. list 2, 2, 2. List 3, 3, 3. List 4, 4, 4. List 5, 5, 5. List 6, 6, 6. List 7, 7, 7. List 8, 8, 8. List 9, 9, 9. Designing a for loop with an array in mind. A for loop can be set so that its control variable spins through a range of numbers that corresponds with the slots of the members of an array. In the array we just declared, we have 10 members that are numbered 0 through 9. Now we need to set up a for loop whose control variable will spin from 0 through 9 inclusive. The term inclusive just means that we will hit the numbers 0 and 9 in addition to the numbers in between. Our for loop would look like this. For int x equals 0, x is less than or equal to 9, x equals x plus 1. This for loop will spin 10 times and hit every number from 0, 1, ... 7, 8, 9. The next part of the problem is to address how to use the for loop to access members of the array. Consider each array member's name. List number. The number is the only part of that changes as you move through successive members in the list. Each array member has the name list followed by the brackets with the slot number inside. We'll use the control variable to represent that number. That way, each time the for loop spins, a different member of the array is accessed. If variable x has the value 0, then list x refers to list 0. If the variable x has the value 1, then list x refers to 1. If the variable x has the value 2, then list x refers to be 2. If the variable x has the value 3, then the list x refers to list 3. ... If the variable x has the value 8, then list x refers to list 8. If the variable x has the value 9, then the list x refers to list 9. Let's start with an example where we use the for loop to print out all the members of the list array. For int x equals 0, x equals less than or equal to 9, x equals x plus 1. Opening brace, see out, list x, end line. Closing brace. Recall that the statement x equals x plus 1 will cause the value in x to increase by 1. This statement allows the for loop to spin. In this case, it allows us to look at each slot of the array during each spin of the for loop. Recall that the statement x equals x plus 1 will cause the value in x to increase by 1. This statement allows the for loop to spin. In this case, it allows us to look at each slot of the array during each spin of the for loop. First, list 0 is printed, then list 1, list 2, and so on. Let's consider some other examples using the for loop to move through the array. In the next example, we will let the user assign the members of the array. We'll put a message for the user inside the loop, as well as an input statement. It will look like this. For int x equals 0, x is less than or equal to 9, x is equal to x plus 1. Opening brace, C out. Please type an integer, end line, C in, list x, closing brace. In order to understand everything that happens in the loop, let's consider the dialogue between the screen and the user. What the user sees on the screen, what the user types at the keyboard. Please type an integer, 5. Please type an integer, 18. Please type an integer, 22. Please type an integer, negative 1. Please type an integer, 98. Please type an integer, 12. Please type an integer, 100. Please type an integer, 24. Please type an integer, 16. Please type an integer, 31. As a result of the for loop's execution, the array looks like a chest of drawers with each of these values in the appropriate box. See Figure 10.3. Figure 10.3. The list array is shown with its values, each in the appropriate drawer of the array. There are 10 members in all. 0 has 5, 1 has 18, 2 has 22, 3 has negative 1, 4 is 98, 5 is 12, 6 is 100, 7 is 24, 8 is 16, 9 is 31. Where 22 is draw number 2 and 12 is draw number 5. Going back to the text. Note that the values in the array appear in the order they were entered by the user. The array simply stores the data. It does not order it in any way. Unless you create code to process or sort the array in some way, the values remain in the order they were entered. Caution: there is no correlation between the array slot and the value in the slot. It would be unusual to have the value 10 in list 10. For example, that would be a coincidence. For loops are the easiest way of moving through an array because you can set the control variables values to match those used for the array's members. Following are some other examples of using for loops with the array. Some short examples using the array. It is important to look at different examples that you will encounter when working with an array. You will want to be able to load, assign an array, print its values, and initialize an array. For example, in this section, we consider some fragments of code that will accomplish these tasks and others. Initializing an array. If you recall, when you initialize a variable, you give it its first value. When you initialize an array, you put a value, usually 0, into each slot of the array. For that reason, the drawers of the array are never empty, and the compiler does not experience any problems when it accesses these members. In the first example, we declare an array of integers and set all the members to 0. Usually, when you initialize an array of numbers, you assign each member 0. Int ages 15. Declare an array of integers. For int count equals 0. Count is less than or equal to 14. Count equals count plus 1. Opening brace. Ages x 0. 0 is being assigned to each slot. Closing brace. In the second example, let's declare an array of characters and initialize each member to the blank character, the space. Here's a fragment to do this. Character, name 20. Declaring an array of characters. For int x equals 0, x is less than or equal to 19. X is equal to x plus 1. Opening brace, name x, quotation marks. The blank is being assigned to each slot. Closing brace. When using the printing an array. When using the for loop to print the members of an array that has already been assigned its values, decide how you want your output to look. If you wish the array members to be listed horizontally, look at example 1. Example 2 shows the array with its values listed on separate lines. Note that in each version, we put the value in X to indicate which member of the array we are printing. Example 1. Character, friend 20, declaring an array of chars. For int count equals 0, count is less than or equal to 19, count is equal to count plus 1. Opening brace, see out, x, quotation marks, friend x, quotation marks. Info will be put on one line. Closing brace. Example 2. Char friend 20, declaring an array of chars. For int y equals 0, y is less than or equal to 19, y is equal to y plus 1. Opening brace, see out y, quotation marks, friend e, end line. Info will be put on separate lines. Closing brace. On the CD. A program that initializes, prints, and then lets the user assign the members of the array. Counting the number of negative values in an array. Imagine an array of 100 real numbers where each real number stands for the balance in a checking account for one individual. If you work at the bank, you would probably want to keep track of the number of people who have overdrawn their accounts. In this fragment, we will count the number of people, array members that are negative, who have negative balances. If an array of doubles has already been assigned its values, we can use an if statement inside a for loop to accomplish our task. Double balances 100, declaring the array int total count equals 0, initializing a variable to keep track of the negative numbers. For int count equals 0, count is less than or equal to 99, count is equal to count plus 1. Opening brace. If balance count is less than 0, total count equals total count plus 1. Total count is increasing each time total count is increased each time a negative value in a member is recorded. Closing brace. Imagine that the array already has its values and that a small arrow is running down the right side of the array. The arrow will count the number of negatives it finds in the array. This total will be stored in the total count variable. See figure 10.4. Figure 10.4. The arrow is shown to the right of the only two negative numbers it encounters. As a result, total count has the value of 2. Let's look at Table A. Balance 0, 428.62. Balance 1, 1496.39. Balance 2, negative 28.75. Balance 3, 271.59. Balance 97, negative 300.47. Balance 98, 528.91. Balance 99, 1657.85. Total count, 1. Table B. Balance 0 is 428.62. Balance 1, 1496.39. Balance 2, negative 28.75. Balance 3, 271.59. Balance 97, negative 300.47. Balance 98, 528.91. Balance 99, 1657.85. Total count, 2. For Table A, the arrow is pointing towards negative 28.75, balance 2. And for Table B, balance 90, the arrow is pointing at balance 97, negative 300.47. Copying one array to another. Let's say you are given an array that you wish to copy. First, you need to declare another array, for example, called copy array, of the same type and size. Then you can use a for loop to copy each member from the original array into the copy array, one member at a time. See figure 10.5. Figure 10.5. Original array is shown passing copies of its values to the empty array, copy array. Copy array is empty. Original array has the following numbers: 19, negative 5, 11, 241, 29, and all numbers are pointing to the copy array from the original array. Now consider the code that will execute this problem. Keep in mind we are assuming that original array has already been assigned its values. Int original array 50, int copy array 50, declaring two arrays of ints. In the middle of the dots, code to assign original array goes here. For int y equals 0, y is less than or equal to 49, y is equal to y plus 1, opening brace. Copy array y equals original array y. Each member of original array is copied, one at a time, into the new array. This section presumes that original array was assigned already, closing brace. On the CD, a program to swap all the members of one array with another. Summary. In this chapter, I introduced the array as a collection of holders for the same data type. An array could be a collection of integers, reals, booleans, strings, or characters. An array is like a collection of drawers from which an array is like a collection of drawers where each drawer contains a separate value, but all values are of the same type. I explained the array through the analogy of a bureau where each drawer of the bureau contains different kinds of clothing, socks, sweaters, shirts, and so on. But they are all of the same type, articles of clothing. When declaring an array, State the type first, then the array name, followed by brackets, with the number of members indicated. The array declaration differs only slightly from other declarations by using these brackets. All arrays have members, like slots or drawers, that are numbered beginning with 0, then followed by 1, 2, 3, and so forth. Take an array called group, for example. The members are called group 0, group 1, group 2, and so on. Loops, especially the for loop, work well with arrays. Whenever you want to work with an array, such as assigning it values or printing its values on the screen, using a for loop to access the members of the array is quite useful. The for loop should be declared so that its control variable spins through the array members. For this reason, most for loops that are used in conjunction with arrays start spinning at 0, since arrays are generally numbered 0, 1, 2, and so on. In the last section of the chapter, I covered different examples using the for loop with an array. We printed, initialized, and then copied one array into another array.